If you were looking for the Primate Cast, don't worry, you're in the right spot. And no, that wasn't a clip of today's guest. That was Hoover the Talking Seal from New England Aquarium, recorded decades ago. But Hoover, along with many other stars in the animal vocal learning world, does come up in a wide-ranging conversation I had with Dr. Tecumseh Fitch about cognitive biology, communication, and evolution. All that and more after the tune.
Evolution,
communication,
cognition,
conservation,
behavior, primatology, typically primates, become the monkey.
Hey everyone, and welcome back to the Primate Cast. I'm your host, Andrew McIntosh of Kyoto University's Wildlife Research Center, and the podcast is brought to you by the Center for International Collaboration and Advanced Studies in Primatology at Kyoto University's Center for the Evolutionary Origins of Human Behavior. In today's installment of the podcast, I am super excited to share a fascinating conversation that I had with Dr. Tecumseh Fitch about the evolution of cognition and communication. Tecumseh Fitch is professor of cognitive biology at the University of Vienna, where he co-founded the Department of Cognitive Biology and plays a leading role in the radically interdisciplinary Vienna Cognitive Science Hub, where they gather biologists, psychologists, neuroscientists, and even computer scientists and mix them up with linguists, philosophers, and musicologists to really understand cognition and communication in their broadest sense. But more than that, Tecumseh Fitch is an icon in the fields of cognitive biology and language evolution. His mastery of these topics are on full display in this conversation, as are his storytelling skills. And we ended up with such a rich tapestry of insight into how language and cognition evolved, how they shaped the lives of animals across the spectrum, from bees to naked mole rats to chimpanzees, and how they've set the scene for our own human experience. So if you want to hear us meander from American Civil War generals to the question of why dogs can't dance, or even find out why macaques could anatomically ask questions like, will you marry me? But to my knowledge are not known to have ever done so. Then stick around for the next hour plus, and I guarantee you will not be disappointed. I always learn a lot through the conversations I have for the Primate Cast, but I gotta say that this one had me cognitively locked in, and I hope it does the same for you. So here's my conversation with Dr. Tecumseh Fitch. Listeners of the Primate Cast won't have heard me ask a similar kind of question in the past, but I mean, I'll start by asking you.
Will not have.
Will not have heard. Yeah.
Okay.
I'll start by asking you, who was General William Tecumseh Sherman?
Well, among many other things, he was my great-great-great-grandfather, and he was a Civil War general. He was the general who, together with Grant and Lincoln, decided on the final policy that ended the Civil War, and did his famous March from Atlanta to the Sea, which cut off the supply lines and basically finally ended the Civil War. At least a year after it was technically or militarily lost, people just weren't giving up. And so from one point of view, I once had a colleague who said, Sherman freed the slaves. So that's one perspective from the South. He's also now rather infamous in the South. So I remember once being in Mississippi, got picked up hitchhiking, and the guy said, Tecumseh? You mean like Sherman? Yeah, William Tecumseh Sherman, that's me. And he was like, you get out of this truck, and if I see you coming again, you better watch out.
Oh my.
So there's a bit of an antipathy towards him in the South.
Yeah, that's incredible how, I mean, I guess now in the kind of moment of our society, there's a lot of reflection on the past, for good and for bad, but sounds pretty intense that can still bubble to the surface in that kind of a way.
Yeah.
For someone who had nothing to do with it.
But I grew up in his shadow. Like I am the male my whole name is William Tecumseh Sherman Fitch III.
Mm-hmm.
And my father and my grandfather and my great friend, they were all Tecumseh Sherman. So, and I have his lucky rabbit's foot and his gold lapel, inherited some stuff, and we have a big painting of him in the wall. So the general was kind of a figure, looming over when I was growing up.
Right. So do you, I mean, this is quite a long history in an American family. Maybe the impression from the outside, and you can tell me if it's true or not, is sometimes like those family legacies seems to have a lot of influence on the descendants in different ways. But I wonder if you have, apart from, the direct experiences of being told to F off basically in the South.
Yeah, that was a one-off. I wouldn't count that as any formative experience.
Of course.
It's just kind of an oddity in my life.
Sure. But do you have like maybe other examples maybe of how it's kind of stuck?
Well, my grandfather was also very successful. And he started a company and then, became a multimillionaire. And so I would say I grew up in the shadow of two great men and always had the assumption that I, too, should be a great man. And I think that's been a weight on my shoulder. And I finally kind of given up on that. It's like, well, I'm doing pretty well in science. I'm having a pretty good time. What else do I need to do, So I guess it has been something of a weight that I've finally offloaded.
Yeah. Well, it seems like you've definitely come a long way since then, and maybe some things that we'll weave into this conversation. But currently, you're at the University of Vienna, and so you started this the Vienna Cogsci Hub, or at least were part of the founding team of that. Yep. And so can you tell us, maybe that's also related to why you're here in Japan with us right now. So can you maybe talk a little bit about the Vienna Cogsci Hub?
Well, the Cogsci Hub came later. So I came to Vienna to create the Department of Cognitive Biology in the biology faculty. But because I have this dual background as a biologist and a cognitive scientist, my PhD is actually cognitive and linguistic sciences, but I've always considered myself and I've always operated as a biologist. I was always an outsider in cognitive science. Kind of like Kuma, kind of like various people around here. We're cognitive scientists, but we mainly work on animals.
Right.
So I went to found this Department of Cognitive Biology with Ludwig Huber and Thomas Bugnar in 2009. And that was really exciting because it's in a biology faculty, but very focused on cognition with some great colleagues. And now we've enlarged the department, and we've been growing and we've been very successful, and we've been supported by the university and supported by funding agencies. So it's now I'm very pleased that I meet students who came to Vienna because they heard about cognitive biology, and so that I would say that's what I really founded. The Cogsci Hub is, I recognized when I got to Vienna that there was a lot of good cognitive science happening, but at different departments, but also different faculties. And the University of Vienna doesn't really have a center, so everybody's distributed all over the city. And what that meant is there wasn't as much collaboration going on as we thought would be healthy. And one thing I've done is got a couple big grants together with psychologists, with various other disciplines and other faculties. And that's been one thing. But then the Cogsci Hub was that the whole idea of that was to really make this a fixture in the university by creating a kind of a center for all the cognitive sciences. And it's kind of dominated by the biologists and psychologists, but we have art historians, philosophers, computer scientists. So it's a very broad mix of people, even for cognitive science, which tends to be very psychology dominated. To have art historians and biologists and linguists is, I think we're unusually broad. So, but that's not a department. That's not, it's an administrative unit without really being a place where students can come. We have a master's program, but not anything bigger than that.
I gotcha.
So, I feel my real baby at the University of Vienna is the Department of Cognitive Biology.
Okay. So coming back to that, you mentioned earlier about how, cognitive science is not earlier, just now dominated by psychology. I've also heard you talk about the kind of why. So why has biology, I don't know if the right way to frame it has been slower to kind of catch on or more reluctant to engage with some of the other thoughts in cognitive science? Or is that the right way to think about it?
That's not the way I think about it. I don't know what the right way is, but from a historical point of view, so I guess when I decided to go into cognitive science, I read a book by Howard Gardner called The Mind's New Science, which was basically an early history of the field of cognitive science. And what he said, and various other reviews of the history that I've read, is that, psychology, computer science, philosophy, anthropology, those were and then neuroscience, which, as it existed in the very early days of neuroscience, those were kind of the founding disciplines. And somehow biology, ethology, sociobiology, behavioral ecology just wasn't there at the table. And, that was a broad enough mix. That was hard enough to pull that together. So I think that's one reason, purely historical, just who was at the meetings. And, ethology was, of course, well established. Noam Chomsky told me that he was reading The Ethologist. Back in the 50s, he knew about Tinbergen and Lawrence, and he was reading that. And that was part of his inspiration for coming up with universal grammar, which when he told me that, I was quite surprised.
Yeah.
But so, I think other than neuroscience, and that was very focused on humans and, maybe animal models of humans, but humans. It was really focused on humans. So I think that's one reason. And I think the other reason, and it meant that cognitive science never really had an evolutionary point of view. That idea which would have come naturally with Tinbergen and Lawrence never got injected in those early days. And then once the traditions are set up, these things have an inertia. Scientific disciplines have their own inertia. I think the other reason is because of behaviorism. And, in one way of seeing cognitive science is it's the triumph of mentalism over behaviorism. And that, by mid-1970s, everybody was willing to accept that for humans. But when it came to animals, that game is still not over. And I think we still, in animal behavior, animal cognition, what we call cognitive biology, there's still a feeling that if there's any behaviorist explanation for a behavior, you have to exclude that. That's somehow to be preferred. Even if it's ridiculously unparsimonious, even if you have to imagine, 10 steps of unlikely reinforcements, et cetera, if someone can come up with a behaviorist explanation, it's our job as cognitive biologists to exclude that. And various people, Dick Byrne has, spent 20 years saying how stupid that is, and I agree with him. But so I think the very notion of animal minds has taken a long time to take off. And, Don Griffin wrote this book, Animal Minds, in the mid-70s. It hit a stone wall. He was very I knew Don Griffin pretty well, and he was very unsatisfied with the uptake on that. To him, it seemed kind of, he had a good term, mentophobia. He said, mentophobia. Animal behavior people are mentophobes. We're afraid of talking about minds. And I think the field of animal cognition, I think now in 2023, we're finally at the point where, at least when it comes to corvids or primates, people are willing to accept it. But I've had psychologists say, I talk about fish cognition, and I won't say who it was, but he said, do you think fish have minds? Like, what an obviously absurd proposition. And I think we have ways to go. But so I think those are the two things. This sort of behaviorism, the ghost of behaviorism is still with us in animal cognition in a way that it was pretty much exercised by the mid-1970s.
Yeah, I gotcha. Maybe one interesting follow-up to that is, how should we think about the definition then of mind if we to determine whether or not we should accept some of the ideas?
Well, as you might imagine, as a founder of a discipline called cognitive biology, I'm very open-minded. And first of all, I take a very broad view of cognition, even in humans. So I would include, for example, emotions. I don't just think of quote unquote higher level cognition, playing chess and doing mathematics, as cognition. I think, the entire reward system is crucial, and emotions are part of that. So I would never make a distinction between, say, cognition and emotional decision making and cognitive decision making. I think anytime you have intervening abstractions over peripheral data and immediate motor actions, you've already got the beginnings of minds. And by that definition, of course, yes, fish have minds. Fish know their way. They know individuals. They know their way around. They have goals and plans and memories. And yeah, what else are those but mental constructs? Yeah. So to me, I have a quite broad. Yeah, when it comes to planarians or flies, I think it's a little bit harder to say. I'm open-minded, but I think showing those intervening concepts is a bit harder. But for honeybees, yeah, I'm happy to say honeybee cognition. Absolutely.
So I think throughout your career, I mean, a big focus has been in the cognitive biology has been on comparative studies.
Absolutely.
And I mean, you've already in 5 minutes, you've already talked about, 7, 8 different kinds of species.
Right.
They're not even closely related to each other. And so maybe you could talk a little bit about how important it is to have that comparative framework when we're thinking about cognition and its kind of evolutionary history.
Yes. Well, I think that's where cognitive science is really missing out, and particularly evolutionary psychology. So the whole idea that humans evolved in the Pleistocene, to me, it's not false in that lots of interesting cognitive evolution happened since our separation from chimpanzees. But most of our brains, most of our minds, most of our cognitive apparatus vastly predates that. And we're not just it goes back to Devonian fish, but it goes back to the earliest neurons. We have the same kind of neurons as a jellyfish. So to me, to take that a broad comparative viewpoint is very natural for a biologist. And it's, what people in behavioral ecology just take for granted, what the ethologists took for granted. That was Lorenz's main thing. We're going to look at a bunch of ducks and figure out how duck courtship behavior evolved. So I think that's a place where that's part of why I ended up deciding to do my PhD in cognitive science rather than sticking with, behavioral ecology, social biology, something like that, is because I saw that strong lack of evolutionary grounding. And the comparative method is our primary toolkit in evolutionary biology. Another thing, so I think that's general. That speaks to, say, primate cognition and comparisons between humans and apes and monkeys. But I think the other value is taking a very broad comparative approach. And even for biologists, this doesn't always go over so smoothly. But having spent a lot of time watching birds and learning about bird cognition, I think they teach us so much about, even though it's convergently evolved, many aspects are convergently evolved, it can teach us so much about why particular cognitive abilities evolve to look at convergent evolution. So I'm not just focused on homology. I think convergence is just as powerful a tool. And I think it's the great, sad fact of evolutionary psychology that at its birth, it was psychology and not comparative. And, I think the good evolutionary psychologists know this and are, do what we biologists think is normal, but a lot of people don't. And so I think I think this is still a work in progress in terms of really bringing an evolutionary viewpoint into human cognition.
That's super interesting. Even Darwin mentioned that our cognition is just a matter of a difference in degree, but not kind. And yep. I suppose that idea didn't take immediately, as most of his ideas didn't take immediately. But it seems like it's taken, you can tell me maybe is that really something that cognitive scientists still kind of debate about, and where might the debates have shifted from the time of Darwin to where we are kind of now in thinking about that?
Yeah.
Are there any huge, great leaps in human cognition that are unfounded, or is it really all just a matter of scale?
Well, just a word about Darwin. So Darwin's notion of natural selection took off like wildfire. Basically, as soon as he published, everybody was like, yeah, natural selection. Sexual selection, which, followed by a few years, equally great idea, took a long time to take off. And particularly the idea of female choice, Darwin was ridiculed by his colleagues for that. So it really took almost 100 years. It took till the 1970s before the idea of sexual selection, in particular, all the Victorians were happy to have males fighting each other and building big antlers. Okay. But when it came to females choosing those males, people didn't want to accept that. So some of Darwin's ideas were very rapidly accepted and others weren't. When it comes to mind, I think Darwin's claim is a very strong one, because is it really the case that a kind of reflex arc that controls a nematode's forward versus retraction response is just a difference in degree from a mental map that a human or a honeybee has? I don't know. I mean, it depends on whether you're a lumper or a splitter. What I would say is, in the same way that there are major transitions in evolution, nicely documented by Maynard Smith and Sainte-Marie, from single-celled life to multicellular life to social behavior, social insect, etc. I think there are major transitions in the evolution of mind, and whether you call a transition a difference in kind or a difference of degree is a matter of taste. So yes, it's a gradual thing in the sense that it's building on what came before, but I think you can have transition, what a physicist would call a phase transition in mind. And I think there are many examples of that. And I think that's part of the power of the comparative approach is we can document those. We can look at a lamprey brain and a advanced teleost brain and a alligator brain and a mammal brain and say, okay, there are various things that happen and they have various functions. We can try and understand what the cognitive implications of those neurophysiological differences are. So I guess I would take issue with, I'm a Darwinian, obviously, but I would take issue with the very strong statement that it's just gradual. And of course, in cognitive science, Chomsky is probably the most famous exemplar of somebody saying, look, language is different in kind from all other systems of animal communication. And, again, it's a matter of taste. I think he makes some good points there. I would say it builds so much on pre-existing, not just communication, but cognition, that there are a few key things, there are a few key adaptations or key components that may be new, but whether that makes the entire apparatus completely new is, as I said, a matter of taste. Okay. And that is that's not what I teach.
Sure. So I want to transition a little bit into talking about communication and also broadly its relationship to cognition. But I don't know if you've written or done much thinking about it, but I was reminded, thinking about language and communication, at least in the primate side of things and understanding, not understanding is the wrong word, but the mid 20th century, later 20th century movement towards the great ape language programs, where there were suddenly a whole bunch of apes, gorillas, chimpanzees, bonobos that were in these programs, raised by people, trying to teach them or have them learn human language. What do you think they get wrong? There's probably a lot of things they get wrong about that idea. But I wonder if you could maybe comment on that as we kind of transition to thinking about communication.
Well, what they got right was recognizing that trying to do vocal communication, which the haze with Vicky, that was kind of the early days of this, trying to teach a chimpanzee to speak, and it just didn't work, and it seemed like obviously a mistake. And I think the great insight of the gardeners with Washoe, and that was continued on, is, okay, wait a minute, give them another modality, the visual manual modality, and start teaching them some signs, and wow, we can get a lot further a lot more quickly. I still think. Well, here we are in the Kyoto research. Well, what is it called now? Here we are in Inuyama, where ape cognition has been a focus for so long. I still think we miss out when we think that the royal road to cognition is via communication, and that you only have human cognition if you have a human-like communication system, so that language is crucial. I think what we know from apes is they're incredibly smart. They can figure out all kinds of stuff. They're amazing tool users. They're amazing wayfinders. They have incredibly complex social interactions and models of each other's knowledge, et cetera, et cetera. I think very sophisticated cognition. But when it comes to communication, they feel a lot more like most other animals to me. They have a set of signals that they use that are very important and very useful, and they can use them strategically, and their context-dependent interpretation. All that is not really very different from what a dog or a cat or any other primate do. when you give them a system like a manual system, or, you give Kanzi the Yerkish keyboard, so he's got this keyboard and he can mix that with gestures. It's a rich communication system. He can use it, but he's not that interested. Mm-hmm. He's it's not like he sits down with Pan-Bonicia, who can also use this system, and they have little conversations or tell each other what they had for breakfast or what I dreamed last night. And I have no doubt that Kanzi knows all this stuff, but the drive to share that information simply isn't there. And I mentioned why rewards and drive are so important. I think humans, the Germans have a great word for it, Mitteilungsbedürfnis.
Wow.
It means a drive to share, essentially, a drive to share your mental contents. And this is what happens when you sit down on a plane and the person beside you is like, "Hey, what's your name? Hey, I just divorced my wife." And it's like, okay, that's a Mitteilungsbedürfnis. And humans, particularly human children, the fact that a 4-year-old just runs around and points at things and says its name, that's something that apes don't do. Mm. Even when you give them the tool, they don't seem to have that drive to share their information. So I think that is one of the crucial ingredients of human language was, in fact, why did that evolve? Why did we evolve to share our mental contents with others? And the fact that chimpanzees don't like to do this is, it's not because they don't have the cognitive apparatus. It's not because they don't know things. They're just not that interested, right?
It's super interesting. And I think you've also found that, so not only is it not necessarily about the cognitive, the neural circuitry or anatomy, but also the vocal tracts. So as I understand it, many species can actually, I don't know if chimpanzees is the right example here, but many species actually can produce speech-like sounds.
Absolutely.
But I think that there's maybe a misconception there, even for myself. I thought that the general consensus was it was part like cognition, part anatomy, but maybe that's not the case.
I would say that, and this is something I've been working on really since my PhD. Mm-hmm. So my thesis supervisor, Phil Lieberman, was the one who came up with this idea that the reason chimps don't talk is because they can't from a purely output, because their vocal apparatus doesn't have the right configuration. And when I first read his book and first started, I thought he was right. I just assumed he was right. And the more I started thinking about it and looking at it and pushing, the more I realized that's a pretty strong hypothesis with some pretty weak evidence. And I've spent a good part of my career knocking that down. So what I would say is that any mammal, certainly a chimpanzee, we've shown it with macaques, but I think it would be true of a dog or a pig. I think it's a general fact of a seal. So we're actually studying seal vocal production. You have a tongue, you're a mammal, you have lips and a tongue and a jaw that can move up and down and a larynx that you can control. You can make all the sounds you would need to have a speech-like communication system. I'm not saying it'll sound exactly like human speech, but it would be enough to work with. So I don't think that vocal tract configuration is the reason that animals don't do this. No, I think it's mainly neural, and as I said, not just kind of computational circuitry, but also reward circuitry. But yeah, you put a human brain in control, not only could a chimpanzee vocal tract speak, but a pig or a dog vocal tract could speak.
That's super interesting. You mentioned seals a second ago too. Mm-hmm. And so maybe you could just transition over a bit 90 degrees to Hoover, the talking seal.
Yeah. Well, I didn't work with Hoover. I will take a little credit in that I sort of rediscovered him, in the sense he was already dead by the time. Terry Deacon, who's a good friend and who's a brilliant scientist, actually encountered Hoover the talking seal walking through Boston one night. And he mentioned it. He has a chapter in his book, The Symbolic Species, about it. And I just started noticing particularly in the evolution of language world, people kind of grudgingly agreed that birds can imitate sounds, but people didn't really seem to accept that other mammals could do it. And that made humans seem much more unique. And, what we now know is that multiple marine mammals, so basically all both groups of cetaceans, at least several seal species, and then bats and elephants and then humans, all of these mammal groups, in addition to to hummingbirds and parrots and songbirds, so about half of bird species, all of these groups can imitate sounds in a way that no other primate can, in a way that chimpanzees can't. So that's a beautiful example of multiple convergent evolution of this capacity to hear a sound in your environment and produce it. So technically novel call production learning. That's what we're talking about here. So it's all over the place. And Hoover, people started saying, all right, we know marine mammals we know that whales can do this because they're learning each other's songs, and you can train dolphins to imitate whistles. Great. Okay. But when it came to the seals, this story of Hoover, people just thought, I don't know, it's some weird thing. It's one paper. It's like on TV, but do you really believe it? And I kind of made it my own. I made it a bit of a little mission to rehabilitate the story of Hoover. And the first time I presented this at a big speech conference at ICVPS in Denver back in 2000. I gave one of my first keynote talks, 300 people in the audience. And I played Hoover, and I had multiple people come up to me afterwards saying, that's bullshit, right? That's a joke, right? I was like, no, it's for real. This is a real recording of a seal. Because you've heard him, right? I mean, I have these recordings.
Yeah.
Hey, Uva, get over here. Uva. Yeah, it wasn't language. He was just imitating the sounds of his foster father. But, like a parrot or like a myna, he had that capacity. And I think that's still the best evidence. We have lots of now more experimentally controlled evidence in in harbor seals and in other seal species, all of it pointing in that same direction. But, Hoover's just this remarkable example. So, Hoover himself is not what's interesting, I think. It's the fact that pinnipeds have evolved the capacity, some pinnipeds have evolved the capacity for vocal learning is what's interesting.
So what is the major, then, evolutionary driver of that? Since you see it in so many different kind of branches of our phylogenetic tree, it seems like there should be a significant pressure towards it.
Yeah, I think there are both pre-adaptations for it, and apparently aquatic life is one of them. So if you look at the organisms that have it, we've got multiple clades of aquatic organisms. We've got birds, which basically need to free their respiration from locomotion, bats as well, flying. So, it's a kind of a weird collection. The only normal ones are elephants and us. How normal is that? So it does seem like there are pre-adaptations having to do with respiratory control, particularly if you're going underwater. You better be able to voluntarily inhibit your inhalation reflex or you'll drown. So that's got to be a powerful selection pressure on any aquatic organism. And I think that's a pre-adaptation. I don't think that's enough, but that's a pre-adaptation for vocal learning. As far as once a capacity is started, what drives it, the two big contexts that we see are song, which is usually territorial, or mating driven. And in many cases in birds, it's only in males. And then in parrots or in orcas or in humans or dolphins, we see it in, equally developed in both sexes. And there, I think it's actually much more about social cohesion, about keeping the group together, about mother-infant bonding and communication. So the infants picking up their own, the signature whistles of their mother and of their community. So I think there are at least those two different selective forces operating. And, obviously in humans, it's not just sexual selection, or we would see big differences between males and females, and we don't. So, yeah, I don't think there's probably a single selective pressure for vocal learning.
Okay. But I had a follow-up, because you also recently wrote a piece about vocal learning in that wonderful species, one of my favorites, the naked mole rat. What is going on here?
The naked mole rat, I think what we have is partial evidence there. I wouldn't, this is what I said in my little review, I don't think we can really say mole rats are vocal production or call production learners yet. I think it's very suggestive and it's very interesting. And I think, as usual, more research is necessary. But yeah, again, weird little organisms, very, very hierarchical dominant system. But yeah, I'm sure that there are other. But I mentioned these the different groups that have it, but I'm sure there are other species. There are other clades which have evolved vocal learning that we don't know about. And in fact, the aquatic hypothesis that I just mentioned would suggest that we should be looking at things like otters or marsupial otters, these completely convergent, beaver, nutria, and any aquatic rodent, muskrats, and basically nobody's looked. So, I would be shocked if there aren't a bunch of vocal learning species, of call production learning species that we don't know about yet, that science is. So part of the field, I think, has been opening our minds to the importance of this, especially when it's convergently evolved, for testing hypotheses like the ones we talked about earlier.
Mm-hmm. And it seems interesting. I mean, humans seem to stand out among the primate lineage, since other primates don't seem to have this capacity.
Yeah. And that's, of course, a big mystery, because unless you buy the aquatic ape hypothesis, which, it's not crazy.
When you mentioned aquatic species, I was going to throw that out there.
There's some arguments there. I'm open-minded. But I think the reason humans evolved it, and there's a lot of argument now that it's a continuum rather than a discrete category, which, that's always true. I still think even what we know, for example, in marmosets or the context dependence in chimpanzees, it just pales by comparison to any songbird or hoover. So I wouldn't say primates have zero vocal production learning abilities, but for some reason in humans it just took off like crazy. And I think that is, Darwin hypothesized that that's because in an earlier stage we were singing like, if you imagine gibbons, which do complex song, and it serves multiple roles. It's territorial, but it also serves a pair bonding. It can serve as a predator alarm. So, singing in gibbons, which has a very, very strong innate component. So you can get hybrid songs if you hybridize gibbons. If you raise them in isolation, they can produce these things. If you put two gibbons of different species together, they each sing their species-specific song, even though they're, acting like doing the male and the female parts.
Wow.
It's I think it's a pretty strongly canalized system. But if you look at the function, you can imagine how, if our Australopithecine ancestors started doing singing like gibbons do, or, maybe we're doing it all along, that there would be advantages to being able to do that to do vocal learning on that, to create more diverse songs, to learn songs from other, or to imitate other sounds. So I think it's pretty easy to see how once you have a song-like system, the drive for vocal learning becomes powerful. That's clearly what happened in many birds. It's clearly what happened in the baleen whales, like humpback whales, etc. So it's an advertisement song that becomes learned. So I think Darwin's hypothesis, this, I call it musical proto-language, deserves a lot more credit and attention than it tends to get in the language evolution world, because of the comparative data, precisely because we know that happens a lot in evolution.
Yeah. I think that's a good place to kind of transition to the role of singing in humans. So I believe one of the main hypotheses that you and others have put forward is that it has a very strongly social bonding function. So maybe you could, and in that case, it's maybe quite similar functionally to gibbons that you just mentioned in the terms of bonding, and also songbirds. It's often used in those. I've studied penguins. I've been out in penguin colonies in Antarctica, and it's quite impressive to see them, the male and female, when they pair, kind of singing and calling together. And of course, they use that as recognition as well, of each other. But I wonder if you can kind of elaborate on that a little bit.
Yeah, I think a really good model for this is the parrots, which are similar to humans in many bizarre ways. And a lot of parrots will be in these fission-fusion groups, and when they join a new group, they adopt the contact calls of that group. So this has been shown and analyzed in detail in budgerigars. So it seems there that part of being a group member is sharing this kind of group signature call. And parrots can flexibly, when they change groups, they can do these different calls. And we don't know that much about the reward circuitry in parrots, but my guess is once you do once you've been introduced to a group and you can do the call and other group members are calling you back, that they get a good little short shot of dopamine and maybe oxytocin or whatever rewards or reward cocktail their brain is producing, because it's part of group membership. Now, when it comes to humans, I think most of my musician friends are like, wait a minute, you published a big, long paper that got a lot of attention saying music does social bonding? It's like, duh, that's so obvious. So I think for a lot of people, that seems obvious. Frankly, to me, it seems obvious. I grew up in a very musical family. Some of my earliest, most precious memories are singing along, where the whole family, my dad was playing guitar, the whole family was singing, everybody was happy. And, I was 4 years old and I was like, this is what I want.
It's incredible.
Yeah. And I've just had a very recent experience. I was in Israel for a month in July, right before everything went very, very far south. And we had a group that got together and sang. And really, by the end of this month, we were like singing almost every night. And everybody in the group would sing along. And we all just fell in love with each other. It was like this giant family after a month. And of course, there were many reasons for that, but I think one of the reasons was that we were doing music so much, and it really inclusive. So I don't think this happens when you have an audience and a band. And, I think it happens with dancing to some extent, but really creating the music yourself, the group creating music together, so that there's this larger whole created by all the individuals. And each person, some people maybe are playing instruments, some people maybe are percussing, some people sing better than others. It doesn't matter. In music, it becomes this canvas, and the whole group can add their strokes to the big picture. And, language doesn't do that. So I think when you ask, why do humans have music and language? Language is great for what we're doing right now. Yeah. One-on-one, dyadically taking turns, sharing information. Language is great for that. But when it comes to taking a community of 10 people and bringing them together, we can chant in unison, in church, but it doesn't have the same thing as where each person fits in some way. Each person is still audible. It's not just about submerging the self into some greater whole. There's still individuality there. So I think music plays a very specific role in human communication precisely because of these design features, being able to create rhythms together, being able to sing in tune, meaning that we all share some model of what the tonic and what scale we're in and what the chords are. We do that, all of that automatically. That's part of, you don't have to be trained as a musician to do that. That's part of our humanity, what Henk-Jan Honig calls our musicality. That's a shared aspect that all humans have. And I think the more we do it, the less death and destruction we would be doing to one another. So yeah, music is social bonding. There are other hypotheses. So I wouldn't say that's by far there's still debate in the literature, but I do think it's a pretty obvious and a pretty strong one. The reason we wrote that paper was because that hypothesis had been kind of dismissed, particularly by evolutionary psychologists, as saying, well, that's group selection. No, it's not. It's not group selection. So we tried to make a good argument on multiple different levels for why this hypothesis deserves to be taken seriously. And that, I think the message has gone over quite well. That paper has gotten cited a lot and almost always positively.
Yeah. We had Henk-Jan Honig here not that long ago. He gave a quick lecture about his work on evolution of musicality and testing across macaques, for example, for rhythmicity and beat perception and all of this. Yep. And of course, we have Yuko Hattori here, who's a faculty here with us, who's also looks at rhythmic entrainment in chimpanzees.
Right.
And so there seem to be some building blocks, I suppose, of music in other species.
Right. Yeah. In the same way that I think the only way to understand language is having a lot of components that are shared and a few that are relatively unusual, like this capacity for vocal learning, I think musicality is exactly the same. So there's a capacity for melody and for learning new melodies, which I call song. And that obviously is a big part of human music. But there's also this capacity for rhythmicity and rhythmic entrainment, which is also crucial. And I think it's particularly crucial for that group bonding, because by sharing a shared notion with a beat, we can actually, we don't all have to like clap in unison. We can do things that build on that beat. So I think rhythmicity in song, I would say dance is a part of musicality. The ability to move your body to a beat, to a shared beat, is crucial. Yeah, and each of those components we can find, I would say drumming, the capacity to make nonverbal percussive sounds. That's something we clearly share with chimpanzees and gorillas, no doubt about it. So yeah, I think each of these components can be found in other species, in many cases, like in song, many other species. And so yeah, it's perfect for the comparative approach.
Yeah.
Because we can find both homologies, like chimpanzee drumming with human drumming, and analogies, convergent evolution, like whatever, parrot dancing and human dancing.
Right, the famous snowball. We had John Iverson as well on the podcast many years ago, and talking about snowball and yeah, really interesting. But you just, I think that maybe part of that also is just maybe there's a reward inbuilt into synchronizing behavior with each other as well.
Absolutely. I mean, I think there can be no doubt. There's some argument about what exactly the neural basis of that is. But for example, we know that just listening to rhythmic music activates motor centers. So Jessica Grum's work and many others now have, and John Iverson as well. It's clear that in a way, even if your body is motionless, your brain is moving to the beat, and that's rewarding. And particularly doing it together, there's lots of nice work showing that doing music together in general has rewarding effects. Robin Dunbar has done a lot. Bronwyn Tarr, many people have shown that doing music together. We have a paper on singing in choirs, so decreasing cortisol. Where the arguments come is oxytocin playing a big role? Is it endorphins, as Robin Dunbar would argue? So I think there's still plenty of open questions. But that, in general, making music makes people nicer to each other, makes them report feelings of more togetherness with the group members. That all seems pretty much to be a fact, and we're just trying to figure out, what exactly underlies that.
That's so cool. You just reminded me about, speaking of oxytocin, dogs are not one of the species that we typically see, any of these, but which is okay. Probably there's no instance of a canid finding any evidence of this, either vocal learning or rhythmicity or whatever.
Yep.
But for dogs specifically, it strikes me as a little bit interesting given our shared evolutionary history now between humans and dogs. And maybe it's not that much time in the grand scheme of things, but there are other ways where we're bonded and synchronized and communicative with each other. And there's morphological adaptations in dogs. And there's been interesting papers about how dogs have hijacked our neurohormone system to make us more attracted to them. So I wonder if this could potentially go anywhere, or if there's any.
Well, I would say two things. Yes, it hasn't been that long. So depending on who's counting, we've got maybe 30,000 years of selection of humans, or we should say dogs and humans co-selecting each other from their wolf ancestors. And we know from very detailed comparisons of wolf cognition and dog cognition that there are differences. These are biological differences. I don't think there's any doubt about that. Frederica Ranga's work at the Wolf Science Center in Vienna also shows that upbringing plays an important role. So if you raise wolves with more human contact, with more human eye contact, they're more like dogs. And if you raise dogs in a more wolf-like situation in packs, they're more wolf-like. So I think we can't just compare wild wolves and domesticated pet dogs. We need to do something like what Ranga and her colleagues have done. But given that, there are still clear biological differences in the last 30,000 years. But when it comes to either of the things you've mentioned, vocal learning or entrainment, dancing, clearly just not there. And what Frederica argues, and I think she's right, is that wolves were pre-adapted for interacting with humans precisely because of the social behavior that they have. They're cooperative hunters. They live in these family groups. They form strong social bonds. It's crucial to their survival. So in all of these ways, they kind of came into the domestication game prepped with some pre-adaptations that have led them to be able to, whether you want to call it hijacking our social bonding mechanisms, whatever. It's a mutual hijacking, mutually beneficial hijacking for the most part between dogs and humans. But you see dogs at a party when everybody's dancing, and they get in the middle and they're wagging their tails. And they know everybody's having fun and they want to be part of it. That's a case where they have the reward mechanism, but I don't think they've got the cognitive mechanism. So, dogs don't dance. That's one thing that has really been pretty clearly. If they did, we'd have much better evidence. Yeah. We'd have some evidence, actually. So I think that's a case where there's a computational mechanism there that you need to have, and dogs don't have it. Same thing with I think if dogs could talk, they would say a few things. You sit.
Yeah, we might not want to hear what they have to say.
Walk.
So, do you think that maybe this will be a last question? And then I have a few hidden questions in here that were given to me by some of your fellow travelers around here, and then we'll wrap it up. But I was just thinking about this communication cognition now with the massive advancements in AI. One of the things people are thinking about a lot is, does it look like we'll be able to improve our communications with other species? And I wonder if that's something that you'd thought about.
Yeah, well, I've thought a lot about it and talked a fair amount about it. And I'm teaching a biodata science course right now, and we're doing machine learning. I think AI is contemporary deep neural networks are incredibly powerful engineering tools. They allow us to solve problems that you simply couldn't solve. And, ChatGPT can translate between programming languages, it's pretty darn good. Yeah, it's pretty incredible. And the image processing capacities for a lot of these different, YOLO and many other models are incredibly powerful. They've got the benefit of petabytes of data and vast amounts of computational power that underlies that success. So I don't think they're very good models for the mind, whether the human mind or an animal mind. But I think they're incredibly powerful tools for animal behavior, and particularly things like video analysis, which is incredibly time consuming. It's one of the most costly aspects of animal cognition research and animal behavior research, is having humans go through these videos and score what's going on and identify the individuals. Now we're really at the place where AI can help us do that. And I think because of that, we can take advantage of all this expense and computation that's gone into training the human models. And with some tweaking and a little retraining, we can make those work with chimpanzees or macaques or birds. That's what we're trying to do in Vienna. And that's great. So that's an engineering tool that allows us to deal with large amounts of data that we wouldn't otherwise be that we wouldn't be able to work with. I think if we then try and correlate that with vocalizations, it's also a powerful tool for understanding communication systems and what different vocalizations mean that can go beyond human intuitions and the very slow work of playback experiments, etc. But I think we need more proof of that. I think that's more of a hypothesis to be tested.
Yeah.
But I think that's going to be the case. I think it will be a very important tool in animal communication research for us to understand what animals are saying to each other with their calls. What I don't think you can do is just drop a hydrophone in the water and record 1,000 hours of orcas or humpbacks or anything else and make any sense of it at all with AI. And what we know from ChatGPT is it'll confabulate. It'll make up. Absolutely. If it doesn't know the answer, it'll make one up. So I'm quite skeptical about that line of research. I don't think AI is going to solve animal language. I think we have a long way to go before you could, for example, have an app where, it can do what I can do now with Japanese and, type in Japanese or even speak. Well, I type in English and it does it Japanese, or I can speak in English and it can output it in Japanese. That's pretty amazing. But those are human languages that have an amazing amount of shared structure. So as different as they seem, they're much more similar. Chinese and English are much more similar than language and dog barking.
Yes.
So the idea that we're going to have a cat translator that turns your words into meows of different sorts, I really think that's nonsense. So I guess I am an enthusiast of AI, but I'm also very wary. The entire discipline of AI is one case of hype after another. From Marvin Minsky in the 1950s saying, okay, we can play chess, therefore we can do language. Nuh-uh, didn't work. To right now, where people think, oh yeah, we're going to solve chimpanzee or orca language by making recordings. I think that's just uninformed and dangerously hyped.
So unfortunately, then we're not going to get the new updated version of the cat singing the Christmas hits in actual words anytime soon. So that's unfortunate. All right. Well, let me finish off by asking a couple of student-seated questions. All right. I canvassed some of the group that you're here with in the autumn school.
Oh, really?
For a few things that they were interested in. And one that I really liked was, let me find it here. What was your favorite animal courtship ritual? And the second part of that, which I love, which one did you use on your wife?
What?
The second part of it.
This must be.
I told him I'm not going to tell you who seeded any of these.
Yeah, no, this must be a reference to this paper I published with Asif Ghazanfar, where our example was, so we modeled the monkey vocal tract to show what we talked about at the beginning, that actually a monkey vocal tract would be capable of producing human language. So we took x-rays of monkeys and we built a computerized model of what a macaque vocal tract could do. And then, we did a bunch of vowels and we did a bunch of controlled psychoacoustic testing, but that was kind of boring. And so I thought, let's see. Bart and I decided to, Bart DeBoer, who's the main computer guy there, decided to do something more fun. And we actually did some Christmas. We did like Merry Christmas and Joyeux Noël and Frohe Weihnachten, because it was around Christmas time. But I also just had some recordings of my wife saying, "Will you marry me?" And the reason we chose that phrase is because it's very continuous. You have continuous formants. And it was just kind of a random phrase. But we did that. We made the monkey say, "Will you marry me?" And it went absolutely ballistic.
No doubt.
Yeah. So that must have been what somebody was getting at. Favorite animal seriously, I've watched a lot of animals in my life, from fish to alligators to frogs to birds to. I would have to say that my earliest days with fish, where they change colors and they do these dances with one another and they vibrate the water, it's just so foreign to us. Like trying to imagine what it even feels like to have someone vibrating in the water beside you and to pick that up with your lateral lines. I'm not sure it's my favorite in terms of the most beautiful, but it's certainly like really opened my mind to how different the sensory and aesthetic worlds of animals could be from a human being's, and yet still be intelligible. It's very obvious what's going on.
Yeah.
But I don't know. I could go on. Alligator bellows. That's an amazing, amazing vocalization that has sent shivers down my spine. So, and, beautiful. Bird song. I love bird song. I really love it. I could spend hours, days and days just listening to birds singing. So I would be hard pressed to say which one is my favorite.
Sure. They're all good.
And I've never used any of them on my wife. So I think that's the only thing that's the only thing that question could be getting at, is that "Will you marry me" phrase from the monkey paper.
That was quite good. I actually wanted to bring that up earlier, just as an add-on to what you were talking about, the larynx structure. Okay, maybe one from Japan here. Do you have what's your impression of the chimpanzee and macaque work here? Do you have any ideas for collaboration with folks?
Absolutely.
Yeah.
Yeah, no, I'm very excited. So Ikuma Adachi and I have been, I've already been collaborating with Takeshi Nishimura, and we had this paper in Science a couple of years ago about vocal anatomy. But we've been talking a lot about what kinds of cognitive tests we can do. So I think there's a lot of places where where you need to do international collaborations where, Inuyama is the place.
Yeah.
And these chimpanzees, of course, are amazing and world famous, but also, the macaques here, the whole facility is such a world international center for primate cognition. I sure hope it keeps getting funded and keeps going strong. It's got a long tradition.
It does.
Yeah. So I think there's really good, very strong grounds for international collaboration.
Cool. So maybe a round 2 in the future sometime then with the updates.
Yeah, absolutely. I'll be back.
What about your cats?
So I just published, we just published a paper, Christian Herbst, who's also here at the Autumn School. We published a paper on purring in cats. And one of the stars of the paper is my cat Stanley, who is a 13-year-old male who has a very strong purr and likes to spend a lot of time on your lap purring. And so I have lots of good recordings of Stanley meowing and purring. And the whole phenomenon of purring has been a very, very interesting one, because what our new paper seems to show is that the old idea is that it was very active muscle contraction, that each pulse of the purr required a muscle contraction, isn't necessarily true. So it seems like the cat's larynx is actually built to purr. And I think that's an interesting hypothesis about a very fascinating phenomenon, but it also shows how sometimes we can be too quick to think something's cognitive when it's more peripheral. But I think we can also make the opposite mistake. I think what's happened in primate communication for a long time is people thought it was the peripheral apparatus, when in fact it's the cognitive apparatus,
right.
It's the neural apparatus. So I guess the big picture story about all this is we should be open-minded. We should never jump to conclusions that something is more anatomic or peripheral anatomy or more neural. We should just treat both as, be open-minded, treat both as plausible hypotheses, and do what we have to do to figure out what it is. And in many cases, it may be both.
All right, last question from me. This one's from me. Now that you're in Japan, you said you've been here before, and you're a big fan of music,
Yep.
Doing music, listening to music, I assume. I haven't asked you what your kind of genre or what you're mostly into, but have you dedicated any time to exploring Japanese music?
Not as much as I would like. So when it comes to my own music, I write songs, and in my the current incarnation, I've been setting great poems to music. So taking Shakespeare or Wordsworth or whatever, great poems from the centuries, and setting them to any genre. And I used to play in a salsa band. I've done African drumming. I played in a rock band. So I do, I have like heavy metal. I have salsa. I have Afro pop. I have all kinds of styles. So I'm a genre omnivore. When it comes to Japanese music, we just had in Kyoto, we went to a temple which had a xylophone, and then they also had this water harp, which uses formants to musicalize drops of water. This beautiful, just amazing soundscapes. And even, is that music? I don't know. It sure sounds good. But Pat Savage, who's a long friend and a long-time term collaborator, is a real expert in Japanese music, and he published a paper looking at Japanese folk songs and comparing them with European English language folk songs. And so I listened to a bunch of that stuff, and I find it fascinating and beautiful, but it's such a huge world that I would say I'm intrigued but completely naive. And I've never done a deep dive into Japanese music. No, not at all. I wish I had time.
Yeah.
It's very appealing. It's very beautiful. So.
Can be quite tranquil as well.
Right.
Maybe from what
That's, I guess I'm more, this kind of Zen garden aspect is maybe more what there's also Japanese techno and Japanese death metal.
Absolutely.
It's a vast musical culture. So
I spent a
I
fair
wouldn't even
amount
know
of
where to
time.
begin to say
Yeah.
Japanese music, as if,
It's a thing that you don't see that much anymore, but I spent some of my formative years inhabiting these kind of underground dungeon live houses full of rock and metal and punk. And so it was kind of a different scene than most people see in Japan. But it always struck me as creative and so many dedicated people.
Yeah.
So.
Well, that's the amazing thing about Japan as a culture is this strange combination. It's a strange combination of innovative and conservative, of traditional and very avant-garde. And it seems like the Japanese can almost absorb anything and make it different, make it unique, make it Japanese. That's true for cuisine, it's true for art, it's true for music. So it is a remarkable culture in that way because, there's so much new stuff. I guess when I say Japanese music, I kind of mean traditional Japanese folk music. But yeah, this, like I said, there's every single genre.
Absolutely.
And, it's kind of an amazing, I think it's an amazing, I love Japan. I think it's an amazing culture. I wish I could spend more time. I think you're lucky to live here. But yeah, so as far as Japanese music, I'm a beginner.
All right, then. I think it's a good place to close. But Tecumseh, is there anything that we didn't cover that you want to mention, whether it's coming back to something that you want to add to or...
Well, one thing I might say that we didn't really touch on, I mentioned at the beginning that both homology and analogy are important in the comparative method. And I think one worry I have in primate cognition is that maybe partly because primatology has often been housed in anthropology departments, there's a tendency to see primate cognition as to see primates as little humans and to be more readily anthropomorphic with non-human primates than we are with, say, dogs people are super anthropomorphic with dogs, but than whales or than seals or than birds. And I think that's a problem for primatology. So I think it's really important that this broad comparative approach, thinking about, say, bird cognition and what it can teach us, is super important. And I think there's really nice work now, for example, with some of my colleagues like Thomas Bugnar working with raven and other corvid cognition and asking, why are these smart birds so much like apes and primates? And there are neural answers, which we've explored. They have a lot of neurons in their brain. But I think there are deeper questions there. And it really will behoove primatologists to take this broad comparative approach and not just stick in, particularly human non-human primate comparisons. I think that's a bit of a dead end. And I think taking a broader perspective from behavioral ecology and, how are marmosets different from macaques, different from chimpanzees, those are just as interesting as how are any of those three groups like humans. So I hope primatology also gets this broad comparative approach. I think that's a super important thing moving forward in the future.
All right. Well, Tecumseh Fitch, thanks so much for joining me on the podcast.
My pleasure. Thank you, Andrew.
Thanks for listening to the Primate Cast. The podcast is hosted and produced by me, Dr. Andrew McIntosh, Senior Scientist for Wildlife Conservation at the Wilder Institute, Calgary Zoo, formerly Associate Professor of Biological Sciences at Kyoto University. Join me for new episodes as often as I can get them out on whatever podcast platform you prefer. Leave a rating or a review of the show to help other listeners find it. Connect with me through our website, theprimatecast.info, or social media on X, Facebook, or Instagram. Feel free to comment, ask questions, suggest future guests, or share whatever else might be on your mind. If you value the show, consider donating or becoming a member. You can do so by visiting theprimatecast.info and clicking on the big yellow Buy Me a Mic button, which takes you to our campaign page. Or you could click on that little heart icon next to the social media links in your podcast player, or on the text link in the show notes. Your support will help cover production costs and is essential to ensure that I can continue to produce quality informational and inspirational interviews with leading figures in the field long into the future.